Here in this video, we are solving two problems from the dual nature of the radiation of the matter that appeared in NEET 2023. Let us see the first question. In a hydrogen spectrum, the shortest wavelength of the Bohr series is lambda. What is the shortest wavelength of the bracket series? So the first thing is we shall know in hydrogen atom, according to Bohr's atomic model, 1 by wavelength can be written like Rydberg constant of 1 by n1 square minus 1 by n2 square. I am not deriving this derivation. I have done it very well in the chapter atoms. You can please go and see. It is given that for Bohr series, Lyman, Bohr, Paschen, bracket, fund is the order. N1 is 2 for Bohr series. For lambda to be minimum, for the shortest value, for this lambda to be minimum, N2 has to be maximum, that has to be infinity. When that is infinity, something by infinity becomes 0. So 1 by lambda will become maximum value because you are not subtracting anything, therefore lambda becomes minimum. So 1 by lambda minimum of the Bohr series is Rydberg constant of 1 by 2 square minus 1 by infinite square. He called that lambda minimum as lambda, so I will call it like lambda. 1 by lambda equal to Rydberg constant of 1 by 4. Or lambda equal to 4 by r. That's one part. Now he is saying for the bracket, Lyman, Bohr, Paschen bracket. So first thing that we need to know is for the bracket series, n1 equal to 4. For the wavelength again to become minimum, shortest wavelength, n2 is infinity. I will use the same formula. 1 by lambda equal to lambda dash. This is a different value. Rydberg constant of minimum of bracket. Bracket means n1 equal to 4 square minus 1 by infinite square. That is r by 16. 1 by lambda dash equal to. It implies lambda dash equal to 16 by r. But from here I can write r equal to 4 by lambda from the first data. Let us substitute that 16 by 4 by lambda, that is equal to 4 lambda. So answer for that problem is 4 lambda. That's how we solve that first question. Let's have a look at the next question that is there in the same concept. Radius of the innermost orbit of hydrogen atom is given for you. What is the radius of the third allowed orbit? So first of all, we need to know radius of the orbit is directly proportional to square of the orbit number, or called principal quantum number. So I can write r1 by r2 equal to n1 by n2 whole square. R1 is given as 5.3 into 10 power minus 10 minus 11 meters, but the options are given in angstrom. To get this to angstrom, you divide with 10 and multiply with 10. So that becomes 0.53 into 10 power minus 10, that is called angstrom. Now R1 is 0.53. R2 we have to find out. Innermost orbit means n1 equal to 1. Allowed third orbit means n2 equal to 3 whole square. So R2 equal to 0.53 into 9. 9 3s are 24. 9 5s are 45 and 2 47 after 2 points. So that is 9 3s are 27. So that's going to be 4.77 angstrom. That's how we get this answer, right? That's it, and thank you for watching.